I want to look at the encoder quickly because looking over the code and just thinking about it a bit, there are a few bugs that I think I've found. One of them is pretty obviously a bug, which is that the lock prefix that I'm encoding is actually just wrong. I've done the test as 0f, but if I go and look at the documentation here, it's actually f0, so I've just got it the wrong way around. So if I flip those and regenerate the listing and do the test again, this should fail. So to fix it, I'll just go to forms, find the lock form, and then just transpose these two hex digits. So now the test should pass again. The second thing is that I have a bug where if I try to output something where I have like a memory operand with a displacement, and the width of the instruction is a byte, it always only outputs an 8-bit displacement, even if the displacement is larger than a disp8 and needs to be done as a disp32. So I think probably the easiest test for this would be to find the mov instructions, which are just here. So let's find mov. Maybe we'll just add it to the end here or something. We'll do like a new test here. So for example, if we did something like rbx plus, I don't know, ox 7f, this one should work as it is right now because the 7f is going to fit into a it's going to fit into, oh, let's do al to make this byte as well. So we'll say byte here. Actually, we'll just take this and just regenerate this test case over here. So we'll just do that and transform this into a test case. Okay, so this should work because the displacement will fit into a byte. So if I do the tests again, that does work. But if I copy this and change this to be larger than a byte, regenerate the listing and do the test, now it's failing because in the case where, you know, I'm using AL here, which makes the width of the form a byte, in the case where the width is a byte and I have a displacement, I always output a single byte displacement instead of the full thing. So the reason that's happening is if I go to Encoder and find width equals byte, basically this width equals byte, and then the displacement is coming in as it's not explicitly being set as a disp32. So it always falls into this append a single byte from the displacement. I don't think this RM check is actually needed anymore anyway, so I could get rid of that. But if I get rid of this, it's probably going to break some other things because I think there are some jump instructions that need to be bytes, which is the reason I put it there in the first place. Yeah, so all of these short forms of jump need to output a single byte. So I think maybe what I would do for those is if I go to forms and have a look for something like, let's see, maybe we'll look for, let's look for JA, I think that might be one that's in here. Okay, yeah. So all of these are op-n-d. So I think if I just special case it to say that if the width is byte and the form's op-n is equal to op-n-d, that should skip over all of those ones. That should special case all of the jumps, but allow a higher sort of bit width for the displacements for other cases, which it does. Okay, so that fixes that. So that was the lock problem and the, you know, just always outputting a byte displacement problem. But there's another problem, which is that if I do something like a no-base memory access, so let's just go into here again and we'll we'll do a no base memory access here for like, we'll just say ECX. We'll do something like, well, we'll do RBX multiplied by 4, let's say. So this will be BX, well, this is actually going to be no base now. And then we've got x4.bx. No base needs to be a memory operand, so no base memory x4bx with a displacement of this. Let's do OX4 zeros, this would be like 64, I think. And then we've got, so this is bytes here, this should be D word now. Let's just do that and regenerate the listing. Okay, yeah, so in this no base case, it's outputting everything correctly, but it wants C9, but it got 49. So let's just go up to the mod RM table. So we've got 8904. Oh, sorry, it wants 0C, but it's actually getting 04. Yeah, so the mod RM, what we want is 0C, but we're getting 04. So 04 is this one here, but it actually wants this one here. Oh, this, okay. That is just because I've done the wrong test for this case. So let's just go and change that quickly. So that's BX. We've got NB, M, BX. So that's doing AX. Oh yeah, there it is. So we've got to change this to CX. So this one might actually be okay, actually. Yeah, okay, that one's okay. I think maybe then it's just a EVEX case. So let's just go to v_add_ps, for example. So this one has base. Basically, in these EVEX cases, I've done the only memory access tests that I've done all have a base. So I think that I just need to add so this will be a compressed displacement. Basically, if I go to Encoder here and look for the compressed displacement stuff, so when you've got a no base memory access, that always requires a disp32. You can't use disp8 at all. And in the normal case, which is why my current test actually works now that I'm looking at it, if the memory operand is not no base, then we allow it to change to a disp8. Otherwise, it stays as a disp32 because it doesn't get in here at all. But there is no no base check for EVEX. So if I've got EVEX with a no base that happens to be able to you know, try and do its compressed displacement, that could change it to an 8-bit displacement when it needs to stay as a disp32. So for EVEX as well, the no base case needs to always output disp32 and never disp8. So let's just create a test case for that. So compressed, I think compressed disp8 is okay for any EVEX. It doesn't matter whether it's Z-word or whatever. But we'll do it on the Z-word test just because, you know, it's a Z-word is always going to be EVEX. So in this case, we've got RCX, which is a base here. If I do something like multiply by 4, that will change it to be no base. So if we do, instead of CX here, if we do no base with a memory access of x4.cx, so CX is the index and it's being scaled by 4, and then we do the same displacements. We've still got the memory broadcasts in there. I think that should be okay for the tests. Let's just regenerate those and then do a test again. Yeah, so in this case, I'm outputting the compressed disp8 for these ones, and then for this one, I'm not sure what's happening here, so we'll just have to test that after I've fixed the no base cases. This might just be a side effect of the no base problem anyway. So let's go back into here. We'll take this no base check out, and we'll just put it up here. So we'll just say, we'll just guard both of these switch cases from like the level above. So if it's the displacement and it's not no base, then we allow it to try and change it to disp8 if possible. So let's just do a test. Okay, so I guess the other case was just probably a side effect of the no base thing as well then. So those are the 3 bugs that I wanted to fix. There's also, I noticed some, there are some encodings that are correct, but they're longer than they need to be. And they're all cases where the instruction has a special like accumulator form. So the easiest one to see this with maybe is like the AND instruction. So we go to the AND instruction, it has these special accumulator forms here, which are being implemented correctly. But it's also got these special forms down here, where you can do an immediate 8 and have it sign extend into the register. So in these cases, let's say that I've got RAX with an immediate 8, it's actually matching this one instead, because this comes first in the forms table. And so if I've got RAX on destination and something that fits within an immediate 32, it's selecting this one, which actually is a longer encoding than just selecting this one, which would sign extend into the 32-bit register. So we'll do some tests for this as well quickly. So we'll do AND. In this case, for example, we'll test 1 and -1, let's say. And the way that I use my immediate constructor function is that it doesn't really take like a numeric value. It's more based on bit patterns. So I don't want to just put -1 into here, because that's going to fill up the entire immediate with Fs the whole way. I'll just explicitly put in 0xFF for this, because this will be like a byte-sized -1, which should be sign extended into the register. In this case, I don't need to worry about it. I can just do a number 1, but I'll just put it as hex to stay consistent. So these two are keyword, which is fine, and then we'll do a test for EAX, which will be the same thing, but instead of keyword, this will be dword. And then we'll do one for AX as well, which will be the same thing, but instead of dword, it's just going to be word. Let's just line those up. Okay, so if we regenerate these tests and run go test, okay, so now this is it's actually getting the correct things. If I do something like echo this into the disassembler, disasm. So you can see this is actually AND with a 16-bit register and the number 1, which is what I had written for the test. In this case, it doesn't actually matter because the bytes emitted are the same length. But for cases with EAX and RAX, I'm actually outputting more bytes than I need to. So if I just if I fix this for all of these, then the 16-bit one will actually match up with what NASM's going to do, even though it's the same width, so it doesn't really matter for optimization anyway. But as far as the 32-bit and 64-bit ones goes, I am outputting the correct bytes for like semantically what the instruction is, but I could be outputting less bytes, so I should select this shorter form, just like NASM's doing. There are a few instructions that this is happening for. If I go to the forms, it's basically instructions where we've got reg-ax as the op1. So if I just go and find all of these quickly. So there's AND, OR, XOR. Test I don't think is actually one of them, but we'll check that. Exchange isn't one of them because that just does registers. That just happens to have a special opcode for the AX version of it. And yeah, I think test probably doesn't need it, but I'll check that one in a minute. So I've got some tests for AND. Let's just go do some encoder tests for OR. I can basically just copy these tests and replace the AND with an OR in this case. So we'll just replace these with OR. So that's OR. Then we've got XOR. Let's just replace those. Next one is test. So test does have these, you know, like we've got like register with an immediate here. Let's just go and check this though, because I don't think this is actually one where I need to do anything special. Let's see, T is down here, so here's test. Yeah, so in this case, there aren't really any special cases for sign extending, so we'll skip tests. Then we've got ADC. So this is add with carry. Then SBB, which is sub with borrow. So we'll just replace these with SBB. Then we've got add. Add and sub. And compare, which is basically just sub. So we'll just change these ones to CMP. Make sure everything's lined up. Okay, let's just regenerate the tests. Okay, so we'll fix ADC first, just because it's the first in the list. Or actually, I'll fix from the bottom here. So we'll do compare. We'll do compare first. So as it goes to forms, compare. So these are basically the MI operand encoding. So if I just copy this one above the current accumulator special case, and just make this one also an accumulator special case, but this time it's matching specifically an immediate 8, then we can tell it to use this 8.3 opcode instead of 3D. So we do the test on this now. So now compare is fixed, so we'll just do the same with XOR and all the other ones. We'll just take this MI case up here. Yeah, I think that's the right one. We'll change this to AX. Okay, then we've got OR, so we may as well just go through these quickly now. So we've got OR, we'll put that up there. So that's AX. XOR will be the same thing. Oh, I already did XOR. Test doesn't need to be done. ADC. SBB as well. This one's just down here, so we'll just copy this up, change that to AX. Add needs to be done. And sub. So I've missed and. Okay, so let's go to and. We'll copy the MI one. And in op1, we'll just explicitly look for AX. Okay, so that was just a quick cleanup for some shorter encodings and then 3 bugs where, you know, they were based on sort of EVEX, compressed displacement, you know, where I was using like a no-base memory operand. lock was incorrect, and then the other one was that in the case of having a byte-sized memory operand, it was always outputting disp 8, even if it needed to output more.